and welcome to episode 56 of the Gaslec podcast. And thank you very much indeed for listening, no matter where you are in the world. In this week's episode, I'm going to be going through what we call here in the UK as Radiator Gate. It's been going on for a few years now. I've been reading up on it, and it's all to do with some manufacturers that sell radiators online are actually lying about the output performance of the radiators and what that can actually mean as homeowners and as for us installers as well. We'll also be going through a trusted website that we do use to do with radiator sizing and the correct outputs, and I'll be explaining how that works as well. And one of our customers last week learned the old saying, buy cheap, buy twice, and exactly how that did affect him. So stay tuned, but first of all, here's my friend Sean to tell you a bit more about the podcast.
Are you a new person coming into plumbing and heating? Are you a homeowner that likes a bit of DIY? Or are you a business owner and wanted a bit more knowledge before you make some decisions on your plumbing and heating? Stay tuned to the podcast and hopefully we'll be able to help you out with some of your questions.
Thank you very much indeed, guys. So I've been looking up on this Radiator Gate that's been banding around for a few years about some of the manufacturers that have been lying about the outputs of their radiators and the implications that it has for us installers out there that are designing heating systems, especially on the low temperature side, and what that means for you as homeowners as well. So I've found a news article on Renewable Heating Hub. And I'm going to just read it out to you here. I'll cut and paste it onto the auto cue thing. So many customers assume in the UK regulations safeguard against forced advertising. Unfortunately, when it comes to radiators, the heat output is not always the case. Millions of radiators are sold annually with inflated heat claims, often exceeding 25% of the actual heat output. This discrepancy isn't minor quibble. It impacts heating efficiency, leading to higher bills and missed net zero targets. The investigation begins to uncover the truth. We purchased 5 radiators from 5 different UK websites. Each claimed for their high heat outputs. The objective was simple: test the radiators at a regulated lab and compare their actual heat outputs with those advertised. The Building Services Research and Information Association is a leading authority in testing who conducted the evaluations. Their testing environment is a specialised, unvented booth with water-cooled surfaces, ensuring accuracy and free from external environment influences. The radiators measured and tested over an 8-hour period with continuous data collected. So the first radiator, now they don't say where these radiators come from, but the first radiator they tested had an output of 953 watts advertised, and the actual output was 760. So it was overstated by 25%. And the second radiator had advertised output of 1,026 watts, and it actually was 786. And that's an overstated amount by 31%. And the third radiator was 26% overstated. Radiator 4 was 38% overstated, and radiator 5 was overstated by 25%. So we got a swing there on those tests, just over 5 radiators, between 25 and 38% of the output. The widespread issues beyond the sample size. The results from these 5 radiators are a representation of a much larger issue playing within the UK radiator market, with millions of units potentially being sold with exaggerated heat claims. The economic and environmental impact is profound, and customers face higher bills, with the nation's net zero targets becoming harder to achieve due to the increased energy wastage. These findings also raise critical questions about the regularity enforcement and the consumer protection. The overstated outputs are not only led to financial losses for customers, but also the betrayal of trust placed in the regulatory compliances and standards. The Manufacturers Association for Radiators and Convectors, MRAC, estimates that a large percentage of radiator products models on offer in the UK may not be compliant with the current standards. The situation is most acute with the directive side of the market, where Mark estimates around over 40% do not comply. Installing radiators that do not conform could result in cold, expensive, and inefficient homes. So what that really does boil down to mean is that in low temperature heating design, what we're trying to achieve, and we're talking about heat pumps and stuff, what we're trying to achieve is the smallest radiator that we can fit in there that's not oversized, with the smallest amount of water content to get the maximum performance out of the system to heat your home. So if you needed, say, 1,000 watts to heat a certain area at a certain flow rate at a certain temperature outside, we need that radiator to perform and to deliver. So if we've got a radiator that's telling us it's 1,000 watts and actually it's only delivering 750 watts, that we're now down by 25% of its efficiency, and sometimes up to 38%. So then what we then do is, then we then get the customers come back to us, and you, the homeowners as well, saying that our room isn't heating up to the amount of temperature that was promised. And then if we start talking about the low temperature heat design, then we start going back to the MCS accreditation scheme. And really, these radiators, nobody really keeps all the technical data on these. No one keeps all the leaflets. You might get them all from one big supplier that have come in, and you might keep one or two, but nobody keeps, or there is no accurate calibrated test data information that actually comes with it. For us to keep and collate and then pass on. So then what happens is, if you've got less heat output physically into your room, you'll have the temperature either running higher, at higher flow temperature, or it'll be running for a lot longer to heat that room up, because it's heating up so slowly. Because the amount of heat you're putting in will have a certain amount of heat loss. And then that's what we're trying to counteract as we move forwards. So yeah, that's the issues with low temperature heating. Us as installers, now I've done all my heat pump installation, my low temperature heating design and heat loss qualifications. Now, and I'm going to be factual here, retrofitted heat pumps at the moment, I don't believe in them. And if I don't believe in it, then I can't be doing anything. And that's just one of my morals, really. New builds, perfect. You've got underfloor heating, absolutely amazing. Swimming pools, absolutely fantastic, crack on. But when you've got, and I've gone through this on other podcasts, when you've got retrofit installations, that's when we can start seeing all these issues. And certainly if we're then starting to get radiators and we don't know the true output of them, then that backs us into a corner. And when we've done all the heating training, they're saying basically it's like a new PPI that's coming out, and we are going to be held liable for 7 years if our design of our low temperature heating system and our heat pump doesn't perform, and the customer can sue us up to 7 years. So this is a really big issue that's out there at the moment. So yeah, I'll just leave that one with you there, guys. So off the back of that, we've got Stelrad, which I'll remember of Mark, the Radiator association there. And they're a UK-based manufacturer for, and trusted manufacturer for radiators. So on Stelrad's website, they have a basic heat loss calculation, and anybody can use it. And what you can do, you can have a look down there. So what it does is that you put in, so when you bring it up, you click on, and the first thing that comes up is the type of room. Now this is important. You've got bedroom, you've got hallway, you've got bathroom, you've got your lounge, your dining room, your kitchen, and all your other options there. And what it basically is that we're looking at a -2 outside, and then we're looking for a general temperature on the inside. So generally living areas will be 21 degrees, your lounges and stuff like that. So it's -2 outside and you're sitting watching the telly, you can maintain that, and that's what the calculation's for. If you've got a bedroom, normally that's around 19 degrees, but it's slightly on the cooler side, and then it varies from room to room after that. So you've got your living rooms, your sleeping rooms, and then you're passing through rooms, your hallways, your landings and stuff like that. So on your first selection there, you've got your room type. So you select that. Then your next option that comes down is your size of your room. So that's typically in meters. So that'll be like 3.1 or whatever it'll be in meters. So that'll be your wall sizes and your height of your ceiling as well. So if you can stand there, and I'm sort of 5'9.5", and I've got little legs, but if I put my hand up, I can't quite reach the ceiling. And typically, if I can't quite touch the ceiling, that's around the 2.4 meters. That sort of number, really. So, but measure it anyway. It's really, really important. And then the next option is how many outside walls. And this is really important because that's where we get all the heat loss from. So when it's going room to room, that's not a massive issue, because if it's in the envelope of your own home, then that sort of heat is being contained to a degree. But that's why this is just a basic heat loss calculation for you. But we're talking about the outside walls. So how many do you have? So then you type that in. And then it's external wall makeup. What is your wall, if you know? Is it a solid brick wall? You've got brick on brick. Have you got a cavity wall? It'll ask you maybe for the thickness of the wall, which is a bit difficult to calculate if you don't quite know yourself. There are some websites that go out there and give you some, when building regulations change for cavities and stuff like that, and cavity insulation, and you can look those up. But what's really good about this website is that you can go through, do your calculations, then go back and then change any of the parameters and see what the difference on the outcome is. So once you've then made up your wall makeup, it's asking about a glazing type. And in one of the other options up there, it'll also ask you about the size of the window as well. So it gives that in square meters. So you then say it's like 1-2 square meters of the wall is an actual window. And the windows are really important because that's got the worst U value for losing heat through the glass. If you've got a nice big thick 250, 300 mil thick wall for the external, and then you've got a window, and that's 2 pieces of glass, and may have a little gap in between, getting on for maybe 25 mil or something. So the windows are the biggest heat loss that we can get. So they ask you glazing type, double glaze, single glazed, hardwood, aluminium, plastic, whatever it'll be. Then it'll ask you for your floor or room below. So if you're on the ground floor, what's the floor made of? Concrete? Is it a suspended floor? Wooden? Is it vented? Is the room below heated? So is it a lounge, and we're pricing up? So we're measuring up for a bedroom. Because if it is, then the heat downstairs will rise and pass through into the room above. So it'll make a difference with that. So then once you get that, it'll then tell you, and it'll tell you how many watts to heat that space. And typically that's -2 outside and 21 degrees. One thing I did miss out there, sorry, is it'll ask you for, I'll just jump to one of the questions there, sorry. It'll ask you for your ceiling or roof type. So it'll say, is there a room above? Or if you've got a roof, is it going up into a loft? If you've got cavity, insulation, insulation went up in the roof space, and then it'll ask your heating method. So in the heating method, it'll ask you, are you using water or using electricity? Obviously, that does make a difference. Then the biggest thing, I'll ask the mean water temperature, and mean means average. So that's talking about your flow temperature to your system. So the lower the flow temperature, the bigger the radiator, and this really comes into low temperature heat design. So then if we've got a combi boiler, say, and we're running at 65 degrees as an average, so we're coming out at 75 and coming back at 60 degrees, and then it will then ask us what the average, which is the halfway point between the two, when our flow returns. So when we start looking at lowering down, and then we can do this actually without having a heat pump. So if you've got your normal combination boiler or your normal heat only boiler, what you can do for that is you can start bringing down the flow temperature, and then you can find out to the point where your house is heating just enough with the minimal flow temperature. Now, what I will say is, if you do have a heat only boiler and that heats up your hot water, you do need to make sure that you can heat up your hot water to 60 degrees. If you're in a standard situation, we'll call it once a week. And if you're in a vulnerable situation, i.e. you've got people with health conditions, they're very old, they're very young, you need to heat the water up to 60 degrees once every 24 hours for the Legionella side of things. But if we're running on a say a combination boiler, that doesn't really matter with it all. So it's just getting that temperature down as low as possible. So then have a play around with the website. And if you can get it down to say 50 degrees, have a look at the size of the radiator you're going to need. And that really will then start to show you how big. And then once you then get that, if you look on the Stelrad website, then it will say you're going to need a 2 kilowatt heater, 2,000 watt heater. And then what size is that going to be? It's going to be 600, type 22. I'm not, whatever, I'm making it up, 1400 wide, wherever the numbers are. And then that will then tell you what size of radiator you're going to need for that flow temperature. And that's what it's all to do with, getting those temperatures down. So what we've been up to last week. So we had a client which changed their combi boiler last week, and we went back, and it was a non-condensing boiler that we changed out. So a year ago, we've gone back to service it. And we fitted I'm sure it's an Alpha E-Tech 28, which got I think that one had the 10-year warranty with it, stainless steel heat exchanger. As I walked through the door, the lady greeted me with, wow, what a fantastic boiler this is. We fitted the boiler in, and she couldn't give me any sort of numbers, but she was saying how much of a difference her gas bills are over the last 12 months compared to her old non-condensing boiler. So she couldn't give me any exact figures, but it was absolutely noted, the difference between the two. And they've been running the temperature. They're both retired. And they've been running the temperature exactly the same on the thermostat, no difference at all on the change there. But they've significantly noticed a difference within their gas usage, which is absolutely fantastic. It's just a shame we didn't get any accurate numbers from it. So we had a customer. So the buy cheap, buy twice. So the customer went to Amazon to buy a new gas hob. So they called us up, and we've worked from before. They said, can you come and fit us a new gas hob? We've got it from Amazon. Can you fit it in for us? Okay, not a problem at all. Existing client, we'll do what you want. So we turned up, we fitted the gas hob, got it all indoors, got it all fitted in their home. And one of the flame safety devices weren't holding on. So these basically it's a thermocouple. So it was on one of the settings there, on one of the rings, the smaller ring. So you had a decent flame to it. You held it down, let it go, and it wouldn't stay on. Turn it on, let it go. Now, fortunately for the client, it wasn't a safety issue where gas was escaping. It was cutting the gas off, but the hob ring would not stay on. So the customer had to then go back to Amazon, buy another one. So now they've got two. And when that arrived a couple of days later, we had to literally go back and install it again. And now they're having to return the other one back to Amazon to get a refund on that. And obviously we're going backwards and forwards here, and our time and labour isn't free, unfortunately. So the whole saying really, buy cheap, buy twice, actually did happen to them, and we're very sorry it did happen to them. But unfortunately, that's the nature of the beast. We had last week we had an air conditioning call out for air conditioning not working. So this was fitted about a year ago by someone, let's just say, wasn't qualified in working with F-gas. So I don't know them, but let's say there was a bit of honesty when the phone call come in. So I went out there myself, and we had all the bits and pieces on, and we done the pressure testing, and the pressure was really, really, really low, and all it was doing was just acting like a fan. So there was actually a leak on the system. So I found and fixed the leak. It wasn't the best of installations. I didn't take any photos for social media, but it wasn't the greatest, let's just say that. So what we have to do is, because the gas has leaked out, there was a tiny bit in there, so we had to then draw out what gas was there and then put it into a recovery bottle. Then we had to then do a pressure test to find the leak onto the system, found the leak, rectified the leak. And then once that was done, and then retest it with pressure, confirm the leak has been fixed, Then we had to vac down and draw out all the air and the moisture out of pipework, which we got down to about 0.2 of a torr, I think it is, which is a pressure testing scale. And then once we did that, then we needed 630 grams of R32 refrigerant, and we put that into the system from our virgin bottle, and we got it up and running. And hey presto, it was all done and dusted. So I got that done last week. I think it was done on Thursday last week, which is pretty cool. We've got an existing client that's moved into a new property. It's right out in the sticks, and where it's been, called us up about some hot water issues, and where the property's been extended over the years. They've actually got 3 hot water systems. They've got 1 boiler and 3 hot water systems. So we're super excited about getting involved in that over the next 2 or 3 weeks. To change some bits there. And now I really want to show you some pictures as well. They had a 100-litre unvented water cylinder and a 150-litre cold water storage tank just sat on top of the floorboards up in this loft. The deflection, and I really want to get a straight edge up there to show you, must be 6 to 8 inches of deflection where it's not being put in correctly. And what they've had to do on the room below, because the ceiling has bowed that much, they've had to then do the ceiling to lower in the group underneath because of the deflection in the ceiling. It's absolutely terrible. I was frightened with my size and weight to actually move across the loft to take a closer look at it. But hopefully we'll be doing that in the next couple of weeks, and I'll run through that as well. So we've got, so next week we've got a new school on board. So we've got a bit of commercial catering next week to do. That's something that I do myself here at Gaslec. So we've got a ventilation fan and an interlock system going into a school. It's in the half term here in Kent. I presume that's actually pre-half term for most of the UK. So we've got to get to do that. We've got a new customer on board. It's a Big Sikh temple. Now, we've done some other works in other temples before, and they have very large kitchens, very, very large kitchens. It's about 20 appliances. So it's actually a massive setup, and in that's I think they've got 2 kitchens actually physically within the building, and they have this wonderful thing. They'll feed anybody that'll walk in at any time as well. So it's a lovely thing. So I'll be working in there next week. And an old pub. So I used to do contract work for Shepherd and Neame via another company a good few years ago. And one of the old pubs contacted us last week. I actually took a phone call and had a chat with the guy. So they've had their system, whatever it is that's gone in. So they want to go independent and get their own catering check done. But yeah, so that's customers contacted us by an old Shepherd and Neame pub. So that's about it for this week, folks. So thank you very much indeed for listening. Have a fantastic week. And if you're watching this on YouTube, you can leave a comment. If you're listening to this on Spotify, you can leave a comment as well as. So we've got it across all the platforms there. So if you need to email us at all to give us any feedback, or you want to be a guest, or you want any questions answered, it's podcast@gaslec.net. Have a fantastic week, guys. Goodbye.